Okay, I hope that you're ready to apply rules of derivation or to differentiate functions applying the division rule. This is what we're going to do in this video because it's a topic that some students have many problems. I'm going to do it step by step with all the requirements for you to completely understand. Let's go. We're going to take this function and we're going to find the derivative of f df dx. Okay? So you can see here that we have two parts. Okay? Like two different functions in a division. So what we're going to do now is to divide, okay, these functions, get the derivatives, and then apply the formula. So we can see that this function could be expressed as u and b. Okay, so u will be the numerator, x plus 1, and b will be the denominator, x cubed plus x squared minus 1. So now what we're going to do is to apply the formula for division. But in order to get the formula for division, we need to get first du dx, the derivative of u with respect to x. You can see it in another video that I did about the chain rule. That is 1 over 2 root of x plus 1. And we need the dv dx. We need to differentiate b. So in this case, we're going to apply the power rule. And the power rule just says that we need to take this power as a factor and subtract one value for the new power. So 3x squared plus the 2x, 2 minus 1 is 1, and this is a constant. The derivative of a constant is 0. So we have the u dx and the v dx. Now we need the formula. So you need to go to any calculus book and find the formula when you have the division. So when you have the division of two functions, the formula will be the u dx times b minus u times dv dx divided b squared. Okay? So what we're going to do now is just replace the values. Okay? So it's something pretty simple. Just replace what we have. So now I'm going to do this process of replacing information. du dx. So I have here du dx. du dx. Okay, so I'm going to write it. 1 over 2 root of x plus 1 times b. So b, I have b here. So times x cubed plus x squared minus 1 minus u root of x plus 1. So root x plus 1 times dv dx, 3x squared plus 2x dividing b squared. So b squared, b is this, so x cubed plus x squared minus 1 to the second power. Okay, so that will be the derivative. Got it? So now you will see, okay, this is kind of many stuff. How could I simplify this expression? So usually when you have this type of expression that has a fraction here, you can see the fraction here. Yeah, you see it? So what we're going to do is to multiply all the expression by the denominator. So we're going to multiply by this factor, 2 times root of x plus 1. Okay? So what happened if I multiply this term by 2 root of x plus 1. I'm going to erase this 2 to write this 1 to write the multiplication. So I'm going to multiply numerator, so I need to add this term here. So 2 times root of x plus 1. Okay, and if I multiply on numerator, I have to multiply on denominator. Okay, and now we're going to see what we can cancel out. Okay, we're going to see what we can cancel out or simplify. So look at that this term is exactly the same of this term, so they will be simplified. And this term, look at that this term, the red x plus 1 is equal to this, but both are roots. So if I multiply two roots, for example, root of 2 times root of 2 is going to get 2, because it will be root of 2 to the second power. So root of x plus 1 times root of x plus 1 is going to give us x plus 1. Okay? So this is just for you to know. So what we have at the end? At the end of this process we have here, that will be 1 times x cubed plus x squared minus 1 minus, remember that these two will be x plus 1. This is a 2, so just 2 times x plus 1 times 3x squared plus 2x over 2, okay, I'm going to put the root first, x plus 1 times x cubed plus x squared minus 1 to the second power. So as you could see, I just apply, when I have denominators, I have to multiply and divide the complex fraction by the denominators I have. Okay? So this is what we have now. What would you do now? What would you do? So far we have done two things. First, we check the division. So we did u and b as a division, and we get the derivatives of each one with respect to x. Then we took the formula for division, and we're simplifying this formula. So now what we're going to do is to simplify this part. To simplify this part, we just need to multiply this polynomial by this polynomial. So like this times this times this, and then times 2, in order to have two polynomials in a subtraction. So my hint, I'm not going to get bored to tell you to do it step by step, because you know it's gonna take us time and we want to finish this math thing quickly. So we're just going to multiply. You can do it at home, like pause the video and do it step by step to see what is the result. So essentially what we got is this, is minus 6x cubed plus 10x squared plus 4x. Okay, after I multiply these two binomials and then times 2. The denominator stands still, okay? Denominator is the same. Now, we're going to just subtract these two. So let's subtract them. X cubed with minus 6x cubed. That will be minus 5x cubed. Positive x squared minus, remember this, minus 10x squared. So we have minus 9x squared. Minus 1 minus 4x. Sorry, minus 1 cannot be subtracted by any other. There's no like terms, so minus 1. Minus 4x cannot be subtracted by any term here, so minus 4x. Okay, so finally we have this form that I dare say that is the final form for our derivative. So this is the f dx. Okay? But what we did to find the derivative of the function using division rule, what we did exactly. Okay, essentially what we did was to find two functions related to any other derivatives and defining as u and b. Then we found the operation, in this case division, and then go to the division rule and apply it, and a little bit of algebra to simplify the expression. This is how you get into this expression you can see here. And this is how you can apply any derivative for any function. Okay? So I hope that this video helped you. I hope that you follow me and like this video and comment. Tell me if you have any question about the information that you have seen here, and see you in the next video. Bye bye.